Okay. So now we are going to look at data science, and data science in it. It is an umbrella. Okay. It's an umbrella of very many disciplines. As you can see here on W3 Schools, it tells us that it combines statistics, data analysis, and machine learning to analyze data and basically extract knowledge and insights from it. So let us try to see how data science is actually data science, how it's different from AI. Okay. And what I want is basically a small, this thing is what I want. And let me just open it in a new, open image in a new tab. That's what I want. So now the difference is that in data science, we are looking at determining processes, systems, and tools needed to transform data into insights, okay, to be applied. And then we use different skills, like we have statistics, data visualization. Of course, we said Python is the primary language that we use. And we have machine learning, okay, ML. And we have, these are database technologies, SQL, SQL, and data wrangling. I defined what data wrangling is in the previous session. And now machine learning, of course, is part of data science. So in machine learning, machine learning is a field of AI that basically gives the machine a human-like capability to learn and adapt through statistical models and algorithms. And in here, we look at things like, of course, it's basically the same that we shall be doing. It's on a continuum. From data science, we go to machine learning, but this thing does not give me a proper description. I think this will. Let me open the image in a new tab and then zoom it out. Oh God, this is the worst quality I have ever seen. But okay, I think this will work. Which kind of quality is this? Anyway, don't worry. So in AI, okay, AI is the broader picture, okay, and data science is just a section of artificial intelligence, okay. So you will never master artificial intelligence before you learn data science, because with artificial intelligence, machines, they learn from data, okay, and you need to first learn how to basically deal with that data. And now we say that data science is all about, first of all, gathering data. So in most cases, as a data scientist, you will be provided with that data. In some cases, you might collect your own. We're dealing with analysis and also now decision making. That's where the machine learning comes from. So we try to find patterns in this data. And then you use machine learning to create future predictions based on that information that you do have. So now, of course, by using data science, companies are able to make decisions. Why should we choose A over B? You deal with predictive analysis, what will happen next, and pattern discoveries. Okay, maybe you're trying to find a pattern, and maybe you're trying to find some hidden information within the data. Okay, so where is data science needed? It is needed in basically all industries. Okay, not limited to these that are here. Whichever industry you're in, probably you need data science to make data-driven decisions. And examples, of course, they're giving us route planning. You have seen how your Google Maps adjust routes sometimes, okay? So yeah, foresee delays in flight, ship, trains through predictive analysis, create promotional offers, best suited time to deliver goods, forecast the next year's revenue for a company, analyze health benefits of training, predict who will win the elections. All that is data. You try to deal with, you try to look at the insights, okay? You try to look at the data that is on ground, and then you use machine learning models to predict who is likely to win an election, okay? So it can be applied to nearly every part of business where data is available. And of course, all of such industries, stock markets, most of you who buy stocks, industry, politics, a lot of industries utilize data science. So you shouldn't feel like maybe I am not going to apply my data science anywhere. So how does a data scientist work? So a data scientist usually requires machine learning, of course, statistics. Remember in the previous session, which was, I think, I don't remember, was it last Friday? I don't remember, but I said that you need to have a basic understanding of statistics. You need to know what a correlation is when you say mean, when you say variance, because that's how you find patterns in data, by using statistics. Okay, dealing with statistical analysis. If we plot a pie chart, you should know how to read a pie chart. If we try to plot a box plot, of course, some of these things we shall be looking at them as we go, but the basic understanding of, if we draw a line graph, what are we dealing with? How do we interpret that line graph? So that is what I mean. You do not need to be a super mathematician in here. You don't need to be that A student in statistics. Of course, yes. I'm not saying you don't need to be, but I'm not saying that you need to be. But if you're an A student in math, that's good. Personally, those who know me know I hated math, but yes, that is how we roll. We need to have that basic understanding of statistics. Then programming, we have looked at Python. Okay, you'll notice that as we go in this data science, you will, well, of course, the syntax looks like, of course, Python, because it is Python syntax, and the libraries that we shall be using will be Python libraries, okay? So everything is built on Python, so the syntax is Python. But of course, there's also another language called R, okay, which I've never bothered to learn, but maybe when God gives me the grace, I'll learn R. So mathematics, not, of course, as I said, not too much mathematics, okay? But because when you're dealing with models, you're dealing with probabilities, okay? So you need to have that basic understanding of probabilities. Databases, we shall have a session where we shall go through SQL, and I'll show you how to deal with, because in most cases, when you're analyzing the data, sources, you might have to deal with extracting your own data from a database. The hospital gives you a whole database and tells you, do you think? So you need to deal with things like SQL, MongoDB, or all those databases, okay? And we have also NoSQL databases. So most cases, but we shall look at databases, and we shall look at how to get data that we already have and also put it in a database. Okay, so it will be exciting when we get to that point. So a data scientist must find patterns within the data. That is your role. And after finding the data, you need to, of course, organize data in a standard format. Okay, so these are the questions that you have to answer as a data scientist. You have to ask the right questions to understand the problem, explore and collect data from the databases, weblogs. We shall look at web scraping. We shall scrape like a FUFA website and try to look at that data, analyze it, look at customer feedback. So basically explore and collect that data, and then extract that data into a standardized format, and then clean the data. So in most cases, you will get data that is not cleaned. So there is a joke that is in the data science community that 80% of the time a data scientist is complaining, okay, about cleaning data, and in 20% of the time he's actually cleaning the data. So data cleaning is a very, very hectic task, but we shall look at it. Don't fear it. Okay, so we clean the data and remove those erroneous values in the data. In this, we look at data. For example, you collected data in the columns where there's supposed to be a name. Maybe there is they have put ages. Okay, for example, in the column where you're supposed to have gender, you have something like email. So you need to make sure that before you analyze your data, you have to first clean that data. Deal with things like missing values. Okay, how do you deal with those? So now, of course, you need to find and replace those missing values, as we said. And these will be the steps, by the way, that we shall be taking whenever we are dealing with a data set. So you have to first understand what the problem is. In most cases, if you do not have the data already, explore it. And in some cases, you have to, of course, extract the data into a standardized format and then clean the data. Okay, this is where you spend some time, and then find and replace missing values. Good thing is that the Python libraries give us a very easy way to find these missing values, and then we have to normalize your data. Okay, you have to normalize your data. So you have to scale the values in a practical range. Okay, so now after that, you start doing the analysis, trying to find patterns, and then you make future predictions and then represent the result. Because when the company tries to look, for example, whoever your client is, if it's a company, if it is maybe yourself, you need to represent the results in a way that people understand. Now, where do you start from? Of course, we are going to look at that, and then we see. So, but before we deal with that, what is data? Data is a collection of information. When we're doing computer studies in senior one, our teacher told us that data is the raw fact input into a computer. Okay, so it's just basically a collection of that information. And one purpose of data science is to provide that structure onto that data to make it interpretable and easy to work with. You are going to get, like, for example, 1,000 images of X-rays, and you need to make sense of that data. Of course, I'm not saying that you need to be a doctor to be able to interpret all those specific X-rays, but if you have such data, images that is unstructured, you need to make it interpretable. Okay, if you have a very wide collection of data, you need to put it maybe in a table or a data frame or something like that, so that you can deal with that kind of information. And of course, data can be categorized into two. We have the structured and unstructured, and we shall deal with all these kinds of data. So unstructured data is usually not organized, and you have to organize it for analysis purposes. And some of this data that we do have, unstructured data, you have like audios, you have images, that kind of data. And then you have structured data that is easier to work. For example, you see unstructured data here. Things are really, they do not have a structure that they are following. But when try to look at structured data that is organized, for example, if it is text, if it is within a table kind of format, it will be easier to work with, because you don't have to first structure it. But even if unstructured data comes, you do not have to fear. You just continue and structure that data. So how do you structure that data? So in most cases, of course, we'll use an array. You'll use a table or a database table to structure and present that data. So that's why I'm saying that we shall try to look at SQL. Okay, example, an array. But of course, we know that this is the list in Python. Okay, So let us try to go into I shared some videos to help us set up our environments properly. Okay. So for those who are using VS Code or Pandas, it will be for Jupyter, it will be easy to work with. So let us go into, we are going to start basically looking at things like Pandas. So let me create, let's create a new notebook. We have seen this before. Okay. So maybe let me come here and create a new notebook. And this notebook, when it is created, let me wait for it to load. Okay. There it is. All right. Pandas, maybe let me call it Pandas 1. Or I can just name it Pandas and I save it. Now, let us try to look at some. I hope is my text small or it is visible in here, or should I increase the cells? It is visible.
Increase.
Okay. Let me try to increase. Okay, I believe there it is. It would be really, really clear. So now, when we are dealing with data, let us try to write, for example, a dictionary. Okay, let me maybe call it person. Okay, so we have seen dictionaries, for example, in Python. Okay, these are key value pairs and it is a data structure. So let me maybe say something like first. Maybe for the first name, I will say Andrew. Okay. I say last, maybe last name. Maybe Andrew, he is maybe Cohen. Okay. And I come and say maybe email. And then I come and say, give him the email, which is maybe andrew@email.com. Okay. So for example, we have such a very beautiful dictionary. And now, of course, we know that to access some of these dictionaries, to access the elements, we are going to use things like, of course, the key to access the value, isn't it? And if I want to access, for example, the email, I'll do the same thing, okay? Use that kind of thing. But now in data science, we have the idea of data frames, okay? Data frames and series, okay? Within in data science, let me make it a very big heading, okay? So now when you're dealing with the data frame, and I think this is where I'm going to use my cargo account. We log into my cargo account. I come to Cargolan and I come to Pandas. Okay. So when I come to Pandas, also it's loading. Why is it loading slowly? Okay, so we look at an introduction of Pandas. Okay, so a data frame is basically usually a table. Okay, or you hear some people say that it is a two-dimension array. So that is basically, in simple terms, it is rows and columns. Okay, so that's what a data frame basically means. Where's the pandas? Where is the? I want to start with pandas. Where are you? Let me just say resume course. But if I resume course, it takes me to. I last opened this thing, I think 2 years or 3 years back. Let me try. I'm trying to look for the introductory part. I can't find it. It's taking me to the very first part. But anyway, so data frames, we are basically dealing with, let me just explain it from here. So we have data frames and then we have series. So a data frame is now, for example, I'm going to import our library called Pandas. Okay, so I've been talking about Pandas, Matplotlib, and NumPy. Pandas is the Python library that has all these functions, attributes, and methods that will help us analyze the data. Okay, Matplotlib will help us draw and visualize our data, draw graphs and all that kind of stuff. Seaborn is built on Matplotlib. It just makes the graphs that Matplotlib has constructed a little bit more beautiful, add color, add all that kind of stuff. Now, NumPy is numerical Python, so it basically helps us perform calculations within Python. Okay, sorry, within your data, basically. So it's numerical Python. Now, to deal with Pandas, of course, we looked at modules when we were in Python. We saw that for you to use a specific module, you have to first import it. Okay, you have to import the module. And we have seen the import keyword. Most of you who were in Ernest's class, you saw him importing some libraries. We saw how we could import the random library, especially when we were dealing with generating OTPs. So it is the same thing here, that you have to first import, okay? You have to first import Pandas, okay? But now after saying import Pandas, okay, you have to put in a statement, maybe as PD. That is the most common standard that you'll find. Import the Pandas library as PD. Now, what is PD? We are going to, PD is representing Pandas because we do not want to constantly type the word Pandas, 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 wherever we shall be. You can even say import Pandas as P, but for you to keep with the standard, we can say import Pandas as PD. So when you run that cell, so you have imported your Pandas library. Now, let us try to write something, okay? So I say PD, okay? Did we see this? Let me copy this, okay? Let me copy this first, okay? So we have this person library, okay? So, but now, and we saw that it is a dictionary, okay? Everyone here knows what a dictionary is. It's a key value pair. And when we come to Pandas, for example, I can create a data frame out of this. So for example, if I say print out person, of course, it's going to bring me this, it's going to print out the dictionary, but I can convert this into a table, okay? And as I said that a data frame is basically a table, rows and columns. But how do I convert this into a table, okay? So let me just copy this again and paste it here. So what I can do is right here, I can say person is equal to, remember we imported Pandas as PD. So I'll say PD dot, and I use the data frame, okay, constructor, and I'll just copy this whole thing and paste it in there, okay? Lists, and I'm going to show you why. So when we are dealing with the data frame, this first part is the column, and this is the row, and the row is supposed to be a list, okay? So when we present person, for example, I get such a thing. Of course, this is not making sense, but let's put our data that we have here, pd.data frame, and let's pass in this information, but now we need to put in these as list, okay? So is supposed to be lists. All right. So what is happening? To syntax error again. This again, I have it here. So when I print out person, I have first, last, and email. Of course, now this of course is similar to what we saw here. Okay, except that here we have a list, but of course you can do the same thing because dictionaries also take in lists. Okay, as the
Doctor,
value. Okay, so yes.
Doctor, good evening.
Good evening, how are you?
When I run my code, I get an error that PD is not defined.
You didn't import Pandas as PD. Okay, always first import that library. So now, this is a data frame. Okay, now we have created a data frame. A data frame is basically rows and columns. Okay, so of course this is a small data frame. It has about just one. We have one row and we have 3 columns. So the columns are the keys, okay, and the values are this part here. Okay, this is the key. This is the value. The values are the rows, and of course we can add more. We can add more values there. Last name. We can put do something like that. Can add more values. John maybe has a sorrow here, and let me just copy this list and then copy, put it there, and let me change this to maybe Josh at email, and I change this to sorrow, maybe something like that. Okay. So when I print out person, okay, I'm going to have this kind of data frame. Okay, this is a data frame. Of course, this is a smaller data frame. You'll be dealing with data frames that have 100,000 entries, 5 million entries, and of course, in most cases, you're not going to define your own data frames this way. Okay. So, but why are we doing this is to show you the structure of a data frame and how do we deal with a data frame. So now when I have a data frame like this person, I can try to access some values that are within, by access, I can access using the column name. Now, when you try to look at this dictionary that we had defined, in the dictionary, we are using this syntax, okay? And it is the same syntax that we shall actually use here. So for example, if I wanted to return the emails that are within this data frame, I'll use person, okay? And then, of course, use my quotes and say email, okay? And now this will return something. Now let us try to wrap this into, we can check for the type of what this result is. But before we go there, let's see. So person email, it returned this kind of format, 0, 1, and 2. This is 0, 1, and 2, of course. These are the indexes, okay? This is the index. You remember indexes. We count from 0, okay? So this is the index column. And these are our basically columns. They have their names, and then we have our rows. So now, in most cases, you also find some people try to access the emails by maybe doing something like that. And it will return the same thing, but this can be a little bit problematic, okay, in some cases. Yes, it works. So, for example, if we had, because if you try to look at this syntax, okay, this is, if you try to deal with email without, if we have something like this would be a method. But if we do not have those brackets, those curly brackets, it would be an attribute. Now we have an attribute called like count. So if you have a data set and you have a column, like for example, count, okay, and say person.maybe count, you are not going to return anything from your count column. It is, you remember our scope, okay, it is going to start from basically looking at that function that is within the Pandas library, and it is going to run the function instead of actually returning whatever is in your column. So what I usually love to do is deal with this kind of thing, whereby I just use the bracket notation and put in my column that I'm basically looking for. So this is a data frame, but what is a series? So a series is, so I can say something like, maybe I can define a series using a series constructor. For example, series and series, it's just basically it's basically a list, okay, of elements. Now, when we look at, for example, this data frame here, when we returned this column of email, we basically returned a series, all right? We returned a series. Now, because you can see it, that here, when we said, for example, let me define a series with maybe names, okay? I say pd dot series, series, not cities, series, and then I put in names like I can say Mary, I can say Jenny, I don't know if that's a spelling, I can say Johnny, maybe something like that, okay? And when I print out names, of course, I'm going to look at this that kind of thing, okay? And now, when we try to check for the data type, for example, of names, okay? Oh, it is actually type. So you see that it is Pandas, it's telling you that this is a series, okay? But what if we checked for the type of actually person, okay? If we checked for the type of person, it tells us that it is a data frame. So a series is basically a row in your data set. A data frame is columns and rows, basically. So I want you to not confuse those two. For example, if you come to W3 schools, it will tell you that a data frame, let's create a data frame. It does not define it. Does it define it? So now we see that column 1, column 2 are the names of the columns. Don't be confused about the vertical numbers ranging from 0 to 4. These are the indexes, okay? And we can access information based on these indexes. We shall see how. And then, oh God, some insect is trying to climb me. So now, a data frame, I wanted, but let me try to get where, because it is very key that you understand what data frames basically mean and what the series are basically about. So I want to do this Pandas. I want the part, this part, creating, reading, and writing. Yes, this is the part. Yes. So a data frame is a table, okay, as we say, and it contains an array of individual entries, okay? And each entry corresponds to a row, or in some, you find people call it a record, and a column. Some people call it a field, okay? So those two terms are interchangeable, a record and a field. So when I say a field, that's a column. When we say a record, that is a row. So for example, we have looked at such a data frame, just that ours was containing names, but let's copy this code and put it within Pandas, okay? Here you might not type along, just observe. So when we run that, of course, pd.dataframe, now we have not assigned it to any variable, so it is just like that. We see that we have a data frame with the column yes and the column no, okay? So, and they all contain their different values, okay? These are the rows, the ones running horizontally, and these running vertically are the columns. So your data frame is that whole thing that has rows and columns. The series are basically the one-dimension picture. So, but let us continue. That, of course, the data frame is not limited to integers. We have seen it in our data frame. We have, for example, emails and all that. And then we are saying we create it using the pd.dataframe constructor to generate the data frames. We have seen that. And then they basically have a structure of a dictionary. And the dictionary, we say that the key is the column and the values are the rows, okay? And sometimes it's okay. I think sometimes it's okay, but sometimes you want to assign these values. Don't worry about that. So the list of row labels used in a data frame is known as an index, okay? So of course, we can have indexes. You can decide to have your own indexes instead of now the ones that are assigned for you, okay? So for example, if you have this, where did we paste the other? We pasted it here, okay? So pd.dataframe, but you can try to also define your own indexes that in case you want them. And how do you do it? You just come outside after the dictionary declaration here, you give them and you create a list of indexes. Create a list of indexes outside there. And when you run that, you have such an index with product A and product B. So this is our index. And now you see that when we continue when we are dealing with data, okay, in most cases, and how is this important, by the way, to list your own indexes? And sometimes you want to label your data when you are, training a model. You want to label the data to tell your machine that the model that you are training. You want to have that labeled data so that it learns when it knows what it is basically dealing with. So in most cases, you have a data set and you're going to find it with these default indexes, the 0 to 1. Not that there's any problem with that, no. But I'm saying that in case you want to sometimes label your data, you do something like that. But now, of course, you can create the index and then you have a table like that. But the series, in contrast, is basically a sequence of data values. And if a data frame is a table, a series is a list. And in fact, you can create one with nothing more than a list, okay? So this is one dimensional, basically, okay? So a list is basically a single column of a data frame. So you can assign row labels to the data, to the series, the same way as before, using the index parameter in case you've created your series. And we have seen this same thing, okay? After creating your series, you can label the indexes and also give them different names. So if I copy this and paste it here, we have the series. This is our series, and we have indexes. The first index is going to be 2015 sales, 2016 sales, 2017 sales, okay? And then we have name product A. So let us try to look at what that is. So the name of this whole thing is product A, and 2015 sales are 30, 2016 sales are 35, 2017 sales are 40. So now basically the series, these are the two main things that you'll be dealing with when you are dealing in data science. You'll be dealing with dataset, data frames, and also you'll be dealing with series. And we said that a series is basically that when you access one column of your data frame, what is returned is basically a series. And we saw that when we try to access person, and we try to access the email of this data frame person. But now let's say maybe we want to also access the first name. Okay, so first name, okay, and email. So you see that wait, person first. Let's try to stay consistent and say email. Okay, are we dealing with, are we still in our data set? Let me see, do I have a key called, let me just copy it down here so that we do not have that kind of confusion. Let me just paste pd.data frame. We have first and we have email. Okay, run that. And when we have person, we try to access, for example, last. Okay, you get something like that. But when you want to access two things, when you want to access the same, another value like email, what you need to do is pass in a list of those columns that you want to return. Okay, and when you return, it is now going, it's no longer returning a series. This time it is returning a whole data frame. Okay, last email, okay, so we see that, so we have basically filtered out the last name and we have filtered out the email. Okay, but if you only have one item that you want to return, okay, just do single columns and say maybe, oh, this email, and then return that code. Okay, so now we have looked at, I don't know if we have now gotten the understanding of a data set, if a data frame and a series. Okay, someone answer me, have we understood what data frame and a series is before we continue? And because everything that we are going to deal with basically depends on our understanding of these two, okay, the data frame and the series. Now we are going to, of course, as I said, that in most cases you're not going to create your own data frames this way, because imagine coding, this is actually supposed to be a list. Okay, so imagine coding out a whole table of respondents of a questionnaire and you are printing them in this way. Okay, of course, this is just to demonstrate the structure of the data frame, but in most cases, of course, you're going to be provided with data. Okay, you're going to have the data set provided to you, and I'm going to, there was a website called Stack Overflow, and most developers know it, and you as also a developer, you should be knowing a website called Stack Overflow. This is where we used to go and ask questions previously before ChatGPT came. Now you do not need to do, not that you do not need, but in most cases you're not going to go to Stack Overflow. But I got a data set that I'm going to share in our chat right now. Let me, where did I get it? Where did I put it? It should be somewhere in my in here, data science. I have these two files, and I'm going to share these two files within our group. I'm going to open my WhatsApp. So let me first stop share. So let me share and create and share these two files. So this is going to be the data that we are going to work with, and why I want us to work with this data is because this is actually real world data. Okay, so I have shared within the group, and the survey results is still loading. Someone will let me know when it is back. Okay, so my screen should be visible again. Okay, so now how do we read data? Okay, how do we read data into this to load it in our Jupyter notebooks or whichever environment we're using? Of course, now when you have a more we shall towards the end we shall see a more professional setup. Not that this is not professional, but we shall see a more professional environment setup where we set up a virtual environment. But now here, let us just read our data into this Jupyter. So now I'll create a data frame and maybe give it a variable name df. Okay, and I'll say data frame is equal to PD. We said PD stands for, who can just shout it out?
Pandas.
Pandas, yes. So, and Pandas has a method called read CSV. So someone alert me when that data set that I've shared in the group is done loading.
It has appeared.
I sent two files. All of them are there.
Yes, they are both there.
Okay, that is good. So we have oh wait, what am I writing? So we have read CSV, okay, as a method associated with Pandas, and of course, when you open those brackets, we're going to provide a path to that file that we are trying to read. Okay, so in most cases, of course, I have it here. Okay, I have it here, and I can just click on it and copy as path. Now, when I copy as path, I'll just come and open my brackets here and paste it there. Okay, so it gives me the path to the file. I need single quotation marks. I don't know why they came to. I need single. So now, of course, now something like that is going to tell me that there's a Unicode error. So we learned about escape characters. So you can just put an error before that and you will not have any issues. So now when we have something like this, we have loaded our data set into Pandas. Okay, so this data set is a CSV file. CSV basically means comma separated values. Okay, but you can open it with Excel still. Okay, so comma separated values is what we call CSV files, a CSV file. So now when I have something like this, how do I basically try to read it? So I can say df. Of course, when I say df, now you see the whole data set gets printed out. Okay, and yes, this is our data set with all its columns and rows. Okay, but we see that, of course, when we have index starting from 0, 1, 2, 3, then as you continue down, you have where this is basically the middle part of the data set, and then you have the last part of the data set, and it is telling you that you have 65,437 rows and you have 114 columns. Okay, so this is a survey from Stack Overflow. and we shall be using this as we go on in this course. So how is this? Basically, when you have such a data set, you want to first know what is this data set all about, okay? What is it data set all about? And of course, I shared also a schema of this data set, okay? There are two. We have a schema of the data set, so let me also load it here and say, let me maybe call it df schema is equal to pd.read CSV, so that we can know what is basically in these. This is the survey results public, and then we have survey results schema. So let me just copy as path, and I will paste it there. I put my R, and then when we print out the DF schema, we shall see what basically this data is all about. We have the first column name, it is saying this is the main branch, which is the best option that describes blah, blah, blah. Then the age, what is your age? So these are the questions that are corresponding to the to these columns. So this schema is giving us which data is in which column, okay? And now how we have different methods that we can use to access the different elements, different columns, and different rows within this data. But before we go far, let us try to see how do we describe this data. So we can, so this schema is just basically to show you that we have this what corresponds to which question, okay? That's why it is there, and it has 87 rows and it has six columns. So we have a shape method. So if I say, for example, let me get back my data set here that is called DF, okay? We just give it a name DF, okay? So we see that we can actually deal with what is, let's check for the type of DF, for example. Now, after loading it, it tells us that this DF is actually now a data frame, okay? And it being a data frame, it is subject to all methods, all functions, and all everything that can be attributed to a data frame. So we can start using our functions on it. So we have a df.shape, okay? So what does df.shape? df.shape is an attribute. It is not a method, so you do not need to put those brackets. So df.shape basically helps us to describe our data, okay? I think I'm rushing a little bit. Have people loaded this data set within the environments? You can just put it on your desktop, wherever, but copy as path, and then paste that path within this within the read CSV method. Someone answer me. Is there someone who has loaded the data set, or we shall be waiting for the recording?
Loaded the schema. I don't know, the 86 and 6th column.
This one of 80. Oh, yes, the schema, okay. But the schema is just basically describing which kind of data is in which columns. So what you can do is load these survey results public. That is the specific one that we are going to be dealing with, okay? So this is a survey done by which website was it? I've forgotten the name. The name has just skipped my mind. So Stack Overflow, yes. So it is a survey done by Stack Overflow from different users, okay? So main branch, I'm a developer by profession. It can be a passion, it can be hobbies or something. Age, under 18, employment, employed full-time, remote, okay? check, which I don't know what this is, but we can find out what check is. Just checking to make sure that you are paying attention. Oh, okay. So what is in here?
Doctor,
yes.
I just wanted to see something, probably missed. Could you scroll down to the schema part?
The schema, this one.
Yeah, I don't know what I missed because I'm getting an error.
You're getting an error. So
It's
you
saying
see,
DF schema not defined.
you didn't define it here. Did you give it a name?
I did.
So when you loaded your data frame in your data set in here, did you load it correctly, and did you run that cell? Because it is important for you to run that cell. It is very important for you to run that cell. If you have not run that cell, so you try and
sure, I've seen.
yes. Okay,
Right.
good. So now okay, so let us try to continue. Where was I? I was saying that we can start with describing our data, try to describe our data. I will describe the data, okay? So this shape, we say that this shape attribute will help you discover how many rows, how many columns are within your data, okay? So, but of course, when we have other methods that you can use. I have something like df.head. Now, we call df.head, okay? And of course, a method, it is going to require it takes in, this head method takes in a value. So I can say something like 10. If I say 10, or let me just say 5, because this is too many rows. So I can say maybe 4. So you're going to return the first 4 columns, okay, the first 4 rows of your data, and we can see it here, okay. We see our index stops at 3. We said in programming we count starting from 0. Response ID is 1, so we are returning the first 4 columns. But then to check also the integrity of our data, we can check for the last rows, okay. For example, if I say df dot now tail, okay, and I put in again 4, I will return the last 4 rows, okay. So what else can we try and do on our data? We saw that we can access columns, we can access rows, but let's I'm going to take it to the rows, but let's first try to check if we can actually access a column, like maybe age, okay. So what if we say something like maybe df, okay, and we say age? What happens? What is wrong? Do you have a column named age? It is capital A. It is a capital A. Okay. So we see something like this. Of course, now it returns this data. It tells us that name, age, length. There are these numbers of rows, D type, object. Okay. We see this D type of object. But we saw data types. We had data types like int, we had data types like float, we have data types like string, we had data types like, who else can tell me another data type that we saw previously? Who can tell me another data type? We have strings, we have floats, we have integers.
Suppose dictionaries.
Okay, the dictionary is a data type. It's a data structure more of the, but we had booleans, we had the true, we had booleans, okay. We also looked at the none type, didn't we? Okay. So now we can also say, okay, we can try to check out which data types that we have. Okay, so we can say df dot p types. Okay, df dot p types, and we can return something like that. Now, try to look at this. Response ID is int 64. This is straightforward. This is an integer. An object, in most cases, that is what a string, that is a string, okay? We have also saying float. This is float 64. It's represented by float 64. Surveilling this object, and all that. So, of course, you need to know the data types of your columns that you will be dealing with. And why do you need to know? It's because when you come to, for example, you're trying to find maybe, is there a correlation between the age, okay, and maybe remote work. Now, initially, these, to find a correlation between two values, they're supposed to be kind of numeric, isn't it? Because you're basically doing some math on those two. So now, what you basically need to first do is you have to first understand, is remote work and numeric? Of course, it will not be, it's not. In this case, we are saying that remote work is, we're saying remote, we're saying in person, we are saying hybrid, okay? This is not a number, so this is a missing value here. So in most cases, what you want to do is try to assign them values. Be like, remote is going to be 1, in person is going to be 2, hybrid is going to be 3, okay? Age brackets, age ranges are already there. So you can try to find a correlation between those two to find if usually younger people have remote work. So see if actually older people will prefer in-person work. So some kind of that kind of thing. So you need to understand, and you need to survey your data to understand the data types of your data set, okay, that you are provided with. So we have seen that we can access columns using of course, what we saw, we can use, we saw the age, for example, and when we returned the age, but if we want to return 3 or 4 items, like maybe, for example, employment, and maybe let me say ed level, okay, let's try to return employment and ed level, and I say that this is supposed to be in a list, okay? If you're trying to access more than employment, if you're trying to access more than one column, ed level is then ed, yes, the L is capital, so something like ed level, and you're supposed to pass this into a list, okay? And of course, when you return something like that, you're going to return a data frame this time. Not now this, when you do something like this, when you return one column, you're returning a series, okay? And we shall see as we continue how relevant this basically is. Now, we have seen that we can do something like that, but what if we are trying to access rows? Can we access a row using in our data frame? So we have two methods basically. We have the lock and the ilock. Okay, we have the lock and the ilock. Let's start with, for example, the ilock, because it is the easier one. So not that the lock is difficult, but this one is the most straightforward. So ilock just basically stands for integer location, okay? ilock, okay? So return data frame dot ilock, okay? Do something like that, and 0. Okay, so it returns the data at the index, okay? We say this is index location. Some people call it integer location, but it is basically an index location. So you're trying to locate by the index. So you just pass in the index, something like as easy as that. Okay. So, but we can also try to, of course, return and see what is at df.ilog. You can try to find out what is on row, maybe 2, 3, 4. That we have something like 65,000 rows. So you can try to find out what is on that. So the name is 2345. That is the row. Okay. The length is 114 and the data type is object. Okay. So now let us try to see what loc does. Okay. So loc takes in two values. Okay. So I said pd dot loc. Okay. So I'll create something like that. The first part has to be the integer, the index. Okay. And then the second value has to be the column name. So that's it. Oh, what is Pandas has no attribute. pd.log. How don't you have pd.log? Oh, sorry. We need the df, the data frame. Okay. So df.log. Sorry, I had done pd here. I just got into my head a little bit, but it is because we are trying to look for the location of this row at index number 2 and the edge in our data frame. Okay. So it is only correct that we do df.log and we say we look for the first one is the index and the second one is the column name. Okay. So that is how we access rows. So of course, if we go to you have a very huge data set. For example, in this case, we have 65,000 rows. There's no way you're going to try and try to visualize all that data. It is not needed. Imagine you're analyzing data from the census. You don't need to know the individual entries. You're just going to do analysis on it so that you have the insight. So now at location number 2 in the age, we have 45 to 54 years old. And of course, I'm not going to go there and double check because that is what is there, even if we did. And we can try it again and say df.log at column, maybe that, and the row number this, and then column that has maybe ed level. What do we have there? This person has a bachelor's degree, a BA, Bachelor of Engineering, etc. Oh God, this guy has a lot of degrees. So now, this is how you access the different data within different columns. And now I want us to first pause here, digest what has basically happened, and I'll share the recording tomorrow morning. I want to make sure that I upload it very early in the morning so that we don't have delays. And then on Friday, we shall have another session, and then we shall basically continue with Pandas, and we shall look at filtering. We shall enjoy a lot of Pandas. So thank you very much for your attention. Do I have any questions?